So what we want to do is we want to learn a little bit about blob as well as the image functions that we have here. So we're going to talk about the blob tool itself, the extract blobs in particular. And we're going to talk about its property sheets as well as its auto-inserted functions. And then we're also going to talk about image filters and kind of how to use them. Now when we talk about blob, we're not talking about that big gelatinous thing that hangs out in movie theaters and likes popcorn and likes to share movies with you. So what we want to do is all that a blob is, it's a set of connected pixels that are above or below a certain threshold. So if I point up at that image up there and I say, look at the image on the left and tell me how many blobs is there, what would you say? Say 2, we say 3. Anyone else want to? 1. Did you know all 3 of those answers are technically right? Because the first question you need to ask yourself is what color blob? So if I say black blob, how many? 1. White blob. 2. Either. 3. See? See how all 3 of those answers could be right? So if I say, look at this other one over here to the right here, how many blobs does it have? The first question you need to ask is, what color blob are you looking for? So if I'm looking for black, 1. White, 4, though you could fight me and say 5, and I'll give you that too. Or either, 5 to 6 or whatever. Add them however you want to say that the whites are, add 1 more to it. So what we're trying to do with the extract blobs is we're trying to find a set of connected pixels above or below a certain threshold. So we're looking for basically either dark on light or light on dark. That's really what it's looking for. So look at all these blob applications. So what do extract blobs do? Well, they're going to detect light features on a dark background or dark features on a light background. And then it's going to give you a ton of information about it, such as X, Y, angle, color, score, area, elongations, perimeters, and spread. Whew, a lot of information. So it's going to let us know what's going on with that little tool. So when we go to add this to our spreadsheet, of course we're going to comment, again, because we're good little programmers. And then we're going to take a look at those holes there. So we're going to go over to our blobs tool underneath the vision tools, drag extract blob over, and drop it inside the spreadsheet. Now it's got a big old property list. Okay, a lot of things going on with the blob tool. First thing it asks for is image, fixturing, region. We've seen all those before. Also asks for an external region, so I don't have to have the rectangular region that's already built in the tool. I can use a composite region or a polygonal region or some type of circular region to it. Beautiful. Number to sort. Now this is special. This has to do with auto-inserted functions. And when did I say auto-inserted functions are created? When you originally create the tool, exactly. When you originally, as soon as you say OK to that property sheet the first time, those are when they are created. So if I say number to sort, if I set that to be 0, the auto-inserted functions will only tell me how many blobs I found. That's it. Otherwise, if I state a number there, it's going to try to find that many blobs, and it's going to print out all that information about each of those blobs. Then I have my threshold. If I put my threshold at -1, it means you tell me what the threshold should be. You're going to take a look at the image, the region that I've given you, and you're going to decide a good threshold. Okay, and I'm going to go with whatever you decide. Otherwise, I can write in a grayscale number, anything from 0 to 255, a very hard limit, saying that is where my blob is. If I'm looking for dark blobs, so anything up to that number will be blob. If I'm looking for light blobs, anything that number and over will be my blob. Fill holes. When it's giving you the area, if you have the opposite color in there, do you want its area to be included as part of your blob? Your choice. Boundary blob. If you have it checked, it says, I will allow a boundary, the thing to touch the boundary. Otherwise, if you deselect it, you're saying, the whole blob better be in there, or cast that baby out. Don't even want to take a look at it. Then we have color of the blob, either light or dark, or white or black, and then the color of the background, black or white. Finally, we have our area limit, min-max. Please don't use this as a range, if that makes sense. Let it find what the blob is. This is to take out like some really big blobs or some little small blobs. I would never put the minimum down to 1. Why would I never put the minimum down to 1? It'll find a lot. It's saying that even 1 pixel deviation away is a blob. So you're picking up noise at that point. And then, of course, our show. So, of course, we're going to put our region around the blob that we're looking for. So in this case, we're going to put it around our leftmost hole. And then remember I said the numbers sort. If I say that's a 0 there, and then I originally okay the tool, then what it's going to tell me is how many blobs it found. That's all it's going to give me. While if I say, hey, I'm looking for 1, then it's going to print out all that information about that blob that you're looking for. This only happens when you do auto insert it. First time you say it. If you mess up at that point, throw away the whole tool, begin again. There is a function you can put in for it, but at this stage of the game, I would say throw away the tool, just start again. Now let's talk a little bit about this threshold and what's considered a blob. So I'm taking a look at my cross up here. So the cross's grayscale is going to be 25. The background around the outside of the cross is going to be 185. So if I'm looking for a threshold of 64 and I'm looking for a black blob, I'm going to find 1 blob. It's going to be the cross. Now if I decrease the threshold to 10 and I'm still looking for a black blob, I find nothing. Why? Everything in the image is above that threshold and I'm looking for a black blob, so there's nothing under 10 grayscale, so it doesn't pick up anything. Now if I increase the threshold to 192 and I'm still looking for a black blob, finds the whole region. Why? Everything. Think of blob as almost doing a binarization behind the scene. You're either blob or not blob. Now if I go and I change it and I say my threshold is 64, but I'm looking for a white blob, notice it just finds the outer region of it, doesn't find the center, because at this point I'm looking for everything above the threshold to be the blob. So what it's going to do is it's going to outline the perimeter of the blob that it found, and it's going to give it a number. So if I'm only looking for 1, it's going to be a 0. Otherwise, if I say I'm looking for 3 blobs, it's going to find 0, 1, 2. By default, extract blobs, if you're looking for more than 1, it will order them in the order of area. So whichever is the largest area will come first, and then whichever is the next largest, so forth and so on. So now what we want to do is we want to decide whether that's good or bad from our area. And so we might use an in-range function. But we've already used an in-range function. That's not as exciting. So what we're going to do is we're going to deal with this thing called snippets. And snippets are sample code. They're a way of creating parts of your program without having to recreate it over and over again. So you can choose a part of your program, and then you can bring it into another one with no problem. Now you might say, how can I create my own snippets? No problem. Choose a rectangular group of cells. Now I say rectangular because it can't be T-shaped or W-shaped or U-shaped. It's got to be contiguous cells joining each other. So it's got to be rectangular. So you would say, hey, this is my snippets area. So you would right-click. You would say snippet, export, and then it will bring up a little directory. You know, you already see some other folders in there. Now, what are all those other folders from? Those are ones that we've already loaded with the software. So we've already put those. So you can stick it in one of those folders. You can say, hey, my cool snippet folder, or whatever works for you. Okay, create a new folder in there, whatever works. And so you can save your snippet there. Because then, when you create your new application, you can go to a cell, right-click, say snippet, import, and go choose your snippets. Now, there's an easier way to import it as well. The easier way is to go to the second tab inside your palette that says snippets, look for the snippet that you want, and drag and drop it into your spreadsheet. Boom. So let's actually try this. So let me put my overlay back on. What I want to do is I want to comment, because I'm a good little programmer. I'm going to say find the holes. Give it a little background. Pop. Okay. So now what I want to do is I'm going to go on up to my blob tool, extract blobs, drag, and drop that into my spreadsheet. Okay. What image am I using? A 0. Yes, yes. What fixturing am I using? Exactly the same as before. My row, column, and angle coming from my Find Patterns tool. My region, okay? This time I'm just going to do them individually. Can I do all 3 at once? Sure. But I don't want to. Okay? So I want to make sure that my region is pretty wide around it. Okay? External region, I'm not using a non-rectangular region. Staying with this one. Number to sort, how many am I looking for? Just 1. Yep. My threshold, I'm going to let it decide the threshold right now. I want to see what happens. Fill holes. I shouldn't have extra little dots in there, but maybe I want to check it just in case maybe a couple of the dots come through. Boundary blobs. I am going to deselect that. The reason I'm deselecting it is, you guys remember Titanic, right? So the thing with the Titanic, you guys remember the iceberg. A little bit of iceberg sitting up, but there's really a big one underneath that just rips open the ship. Think about this. If I made my region too small, so what might happen is there's enough of my blob in the region that it meets the requirements that I have for the inRange function, but the rest of it might be gouged all out here. Well, guess what that is? A false accept or a false reject? False accept, which what did we say about false accepts? Not happening. That we are not going towards that. We want to make sure that the blob is totally inside our region. If it's touching the boundary, we say all bets are off, I don't trust it, I'd rather have a false reject. That's why I have it a little bit big around it right now, so it can move a little bit, especially with fluorescent lighting. You're going to notice that Find Patterns moves a little bit, and we're still good. Now, what color blob am I looking for? And what color background? White. I'm going to leave these alone, and then for my shows, I'm going to do result graphics only as well as the input. So I want to get the green perimeter around it, and I want to get where my search region is. Okay? So if I go ahead and say OK, then sure enough, what it puts inside my spreadsheet is all this information about my blob. And I'm going to go in there again, and I'm just going to say Format, and make it a little bit thicker so I can see it behind my image. So now what I want to do is I want to do another one. So I'm actually going to do Extract Blobs, and I'm going to put it right underneath the first one. Why don't I drop down an extra row? The headers are all the same. So why have two sets of headers in there just bogging things down if they're all going to be same and line up? So the image, still going to be A0. My fixed string, still going to be my row, column, and angle coming from my Find Patterns tool. My region this time is going to be that center one. Okay, make it a little bit bigger, but that is happy. Beautiful. Say accept. Looking for one, fine with the automatic thresholding, fill in my blobs, deselect boundary. Color of my blobs, once again, is going to be black on a white background, and then turn on my input and result graphics. So almost exactly like the one before, just my region's changed. Okay? So now if I go ahead and say OK, sure enough, so it looks great. Wonderful. So now, is there an easier way to do it?
Oh, you think that we can just copy and paste? Well, let's try that. So if I right-click on this and say copy, and put this right down here, and I go paste, uh-oh, what just happened? These are auto-inserted functions, so they are inserted at the time that you create the tool. Did you just create the tool right now? Nope. So let's try this again. So let's go, and this time let's grab all the area. We're going to say right-click, copy, come down to here, right-click, paste. Now notice they're the exact same numbers. Should they be? Most definitely, because we're dealing with the exact same image with the exact same function. So they better be the exact same answers. So now all I have to do is go into this third blob, double-click it, go to my region, and this time I'm going to put my region around the smaller blob. I'm going to say OK, and then OK, and sure enough, there's my blob.
Okay, so my blobs, you'll notice that when I copy it and paste it, they're the exact same number. They better be. It's the exact same settings on the exact same image. So if I start getting different numbers, we got issues with our algorithm. So now all I need to do is I just need to go into my third blob, double-click on region, and just move it over to the new region. Now I'm not sure why it hasn't acquired yet. Okay, let's just do an F5. There we go. Now what I want to do is I'm going to take from elongation to spread, and I'm just going to delete. Is it gone for good? No. It's still sitting inside those structures. If I needed to get that information out, I could. But the thing is I really only need area. That's all I really need here. I could get rid of the rest if I wanted to, but I'll get rid of this last part of it and just have my area. So now what I want to do is I'm going to go to snippets. I'm going to go underneath, this would be a math and logic tool. and it's called check tolerance. Now, this column next to it, please leave me that open. Okay, I'm going to do something with this column tomorrow morning. So normally I would think I would put my snippet right next to it. But because I've been doing this forever, I happen to know the snippet has 2 layers of headers. So I'm just going to go one above it. And as soon as I drop it, it says range checks the value cell. And it says my value. Now right here, as I hover over it, it has this little reference right here in the corner. It says reference the cell to be range checked. So what cell do I want to check what its value is? The area, yeah. So I'm just going to double click on this cell and reference the area and accept. Now, notice how it's 12,000, okay? When it asks for the minimum, please do not try to push it up until 12,000. You will break the system. You will basically lock up the PC. You start sending so many events, it doesn't know what to do with it. Don't do that. Type it. So what I might say is anything from maybe 11.5 to maybe 12.5. Beautiful. So as soon as I set this up, notice it now says a nice 1 here. In fact, what is that 1 talking about? If I actually click on it, it's doing an in range function. It's doing an in range function where it's looking at this and checking to see if it's between these 2. How awesome. Not to mention, it gives me a pretty little LED. So now what I can do is I can just grab this, right click, say copy, paste. So beautiful, everything looks great. And now just this lower one, I might want to change that around to maybe be from 4,000 to maybe 3,000. Okay, let's give it something just so I have some numbers in there. So now what I want to do is I want to check what the total is. And I'm not just talking total serial. I want to find out, make sure that all my values have actually gone to some type of good status. Now, what logic statement would make sure that all these are good? An AND. So I can go back to my functions because my snippet's sitting here. So I go back to my functions, my mathematics, pull my AND function, so that'd be underneath logic, and I can just grab it, just like I could Excel, grab all 3 of these and accept it. ANDs them all together. Finally, I can just do a right-click copy, right-click paste of the LED, and now I have a little LED there too. So now let's go ahead and go. So far it's looking good. Let me test this out. Let me take something and mess up my holes here. So if I come in here and I stick something there, oh, that hole's error. Oh, you know, why don't we change that around?
Why does it work?
I'm not sure why it works. You're right. It has always kind of worked, but I think it knows that you're stupid, and it corrected it for you. Meaning me, because I... Now, did you notice what I just did? I edited while online. These cells, well, this falls into the same categories. These cells are called edit cells, and these cells are allowed to be used while you're online. We'll talk more about that when we do the designer interface tomorrow. But there are certain functions. Take a look at those little comments right there. Let me just go offline. If I go and say right-click on here, what I can do is there is edit comment, or you can insert a comment if it's not there or whatever. And so it allows for you to say what color it is and what is the flyover comment. So you can add any type of comments you want to any cells to help people. You know, a little flyover and say, nope, don't be touching this. So let's go ahead and get through this last section for today. Image functions. So what these do is they do some image processing. The whole idea behind software image processing tools is that we either want to enhance certain features or diminish them. It's basically that we've tried everything we could to get a good image. Couldn't just get it with lighting and optics and everything. So now what we need to do is we need to manipulate the image a little bit to give us a better one. And then that can be fed to our tools. So that's where our image functions come in. You've got your original image. You can enhance that image, and then that can go on to your vision functions. So we have compare image. Now what compare image does is template matching. That's really what compare image does. You have what you train at design time. This is your ideal golden template. And then you're going to compare it to what you see at runtime. Now this tool works best if you use it with PatMax. If you don't use it with PatMax, it starts jumping all over the place and you start getting erroneous errors, things that just should not be there. But what happens is that anything that is same is going to look dark. Anything that is different is going to look bright. So in this case, I might have had my model image, but here's what my actual one at design time was. So what it does is it takes my design time image minus the model image, and this is what it comes out with. So you can see it looks like the holes are not centered in the same areas as each other. We can see that the text is kind of different in there. Our 2D matrix is different, and we've got this gouge. So now we've got this image that has these light specks on it, and we need to decide whether we have defects or not. What tool would be great to use for this? Looking for something like light on dark of connected pixels. Blob. Histogram maybe, but probably blob would be more likely. So in your blob tool, so where it asks for A0 and you guys all kind of laughed at me and said, ha ha, image is always A0. No, it's not. Now what I can do is I can reference the image processed image, so that difference image there. And so now I'm looking at that and I'm just looking for anything that's light on dark. And maybe for my number to sort, I put it at 0, so that all it will tell me is how many it found. So now if I get anything other than 0, I know I have some defects on it. Beautiful. So it's a nice down and dirty defect detection. Now we can also use neighbor filters. Now neighbor filters I like to call our kinder, gentler tools. They care about their neighbor. They say, okay, I've got to change my color. What color are you? And what color are you? And what are you? Okay, and this is how I'm going to change my color. Okay? So that's what neighbor filters are. They take into consideration the pixels around it to change it, such as erode. What erode's going to do is it's going to shrink white areas. It's going to make dark areas become enhanced. Now the truth is this 2D matrix we can read anyway. But this was old school. This was when we couldn't read it. So what we might want to do is we might want to enhance the dots a little bit. So what I can do is I can put in a little road filter on it, and it makes the dots pop a little bit more. It makes the white go away, makes the dark a little bit bigger. Now I can read it. But I've got to be careful of my kernel. The kernel always has to be odd because your pixel of note is always in the center of it. And then if you go too big, you can actually start making it look bad again. So here I've got 11 by 11, and now my dots are starting to come in and starting to hit up against each other, and that is not what we want. Okay, so erode is just going to shrink white, increase dark. Now the opposite is dilate. Dilate is going to expand white areas, shrink dark areas. This was our old OCR tool. So our old OCR tool, it basically did a blob analysis behind the scenes. So what could happen is if I had a bunch of little specks on there, it could really throw off my scores. Because it's doing the binarization, it says, no, this isn't quite what you trained it to be, and it basically throws it out. So if I did a little bit of dilate on it, I can basically take out those little dark spots and everything, and bam, no problem. Now I can read it much better. I have much higher results in it. Our current OCR tool, this would mean nothing to it. It could get through this without even breaking a sweat. Our point filters are narcissistic tools. It's about me and only me. Okay? I don't care what your color is. It's only about what my color is. Okay? That's all I care about. So it's about me and only me. So if I do something like a binarize, I don't care what the points are around me. I just say, am I above or below that threshold? If I am below that threshold, I go to 0. If I'm above that threshold, I go to 255. That's it. So that image is going to look very different depending on where I've set that threshold. Okay, how much more white or how much more dark I'm going to have in there. Then we have clip. Now what clip tries to do is it tries to diminish your shadows and diminish your glare. Whatever the minimum point is, if you are a grayscale value below the minimum, it clips at the minimum. If you're a grayscale value above the maximum, it clips at the maximum. So you might say, well, what is it used for? Once again, our old OCR tools, how they did blob. So if I had any type of glare around it, it would consider that as part of it. So when it would start training characters, it would really throw off the characters. It ends up getting this blobby mess there. But if I did a clipping, now what that's going to do is it's going to basically take out those hot spots. So now I can get a better representation of what that character looks like. Now stretch kind of does the opposite. Stretch says if I'm at my low value or below it, I push it down to 0. If I'm at the upper value or above it, I go out to 255. Because what we're trying to do here is we're actually trying to enhance shadows. We're trying to enhance glare. In fact, we're trying to increase your contrast. So it's trying to set it up. Now, even in the center, it still kind of spreads them up a little bit in the center as well. So it's not just straight grayscale and then it hits the tips. But it's trying to increase that contrasting. So we've talked a little bit about the extract blobs, and we talked about some of the auto-inserted functions that go along with it. We've talked a little bit about the image filters. We have the compare image, which just does a template matching. We have the neighbor filters, where the grayscale value is going to change depending upon what the other pixels are around it, while we have the point filters that it doesn't matter what the other ones are. It's going to change just what itself is, and that's all that happens with it. We also talked a little bit about snippets as a way to save code and reuse it later. So let's see how the Binarize tool works. Dun, dun, dun. So I'm going to put a little comment. I'm going to say Binarize part. Okay, let's get a little bit of... So maybe what we want to do is we're looking at this and we might want to say, you know, I might want a lot of this to just kind of go away. Maybe I'm just concentrating on just this area up here. How can I make this back kind of go away here? So let's see. So I'm going to go over to my image. I'm going to look at my Binarize image. And this could also, this will be a point filter. This could also work, especially if you're having some light to dark, dark to light transitions on the part itself. Maybe you're trying to say that, you know, I need a tighter look for my block. Well, let's drag in the point filter. Now the point filter says, what image do I want to use? Well, what image? A0. Still a trick because I don't have any other images on here. Okay. My fixture, I still want it to move with my part. So I'm going to choose the row, column, and angle coming back from my fine patterns. And then my region. So maybe I want to set my region up to just kind of look at my part like this. So if I go ahead and say OK, notice it already took care of that. Now I've got a little bit of smudge right here, because if we take a look at it, right now it's saying that I'm in auto. Okay. What I might want to do is, if I want to get out of auto, let me actually just place a number in there. So let's just go 128 to start with. So let me click off of it. Doesn't change it much. So let's see what happens if I increase this. So let's say 140. Oh, notice how it's getting darker. I probably don't want it to get darker. So let's go the other direction. So let's say 100. Okay. And notice that it's starting to pick up over there. If I wanted to, I could say 75. And notice how it starts picking up more and more of it. So maybe something like maybe 102 might be a good one to basically knock out most of my part, but leaving my holes nice and clear here. The only reason why I'm clicking off of them is because I don't want to enter, because then it closes the tool and everything. So I'm just clicking off to another parameter there just so it accepts it. So if I wanted to do my blobs off of this instead, so if I say OK here. Now, one thing I guess I should say, we also have this. As soon as I come off of it, I go back to seeing the regular image. But if I go to run, I don't see the image. And if I'm going to be using tools on this image, what I might want to see what the actual image looks like. So this is where, in my hide all, the results graphics is the actual graphics coming back from it. And then the input graphics is just the region that it's using. So I'm just going to use the result graphics so I can at least see it. So now if I decide that this blob, instead of it coming off my grayscale image, I want it to come off my binarized image, I can just reference the new image from there. And so now it's going to be based off that binarized image there instead of the grayscale one. Does it affect it much? It seems like it added a couple more pixels in there, because some of the things that might have been right on the edge there, it now pushed it one way or the other. And so now it decides whether it's blob or background there.